It looks like I'm alone. Oh, well, one other person just logged in. Okay. I'm going to continue. I'm going to start the stream. And as people come in, you can let me know you've entered. I'm just going to work through these exercises that are at the end of the unit. Now, as I explained, these from these 4 questions, I'm going to derive a similar problem and put it on the final exam. So practice these, and you should be ready for that problem on the final exam. Okay, so this is the only one that doesn't have a solution worked out. So I'm going to start here. This problem: each year, employees of a large company receive a Christmas bonus of $500 plus $100 for each year they have worked for the company. All right, so based on the number of years that an employee works, they're going to be compensated with a Christmas bonus. Well, they're going to get the Christmas bonus anyway, but depending on how long they work, they're going to get extra, $100 for every year. All right, so that works out to creating a new variable. We'll call it y, and it's based on x, and x has a distribution that the parameters given are 6.7 for the mean and 2.4 for the year. So on average, employees have been at the company 6.7 years with a standard deviation of 2.4 years. So how can I use the information on the number of years that they've been at the company to compute the average and standard deviation of the bonus that they get? So this is a direct application of the rules of means and variances to do this. So let's just recap from which formulas should I use. Okay, well, this is a linear transformation. So I've done something. I've done something like this, right, to the variable. I've multiplied it by something and I've added a shift term. So we amplify the value and then we add. So I'm going to use this property. This is how the mean gets affected. I do whatever I do to the variable, I do to its mean. And what about the standard deviation? The best formula to use is, well, this is the formula here for a linear transformation. For the variance, the shift term doesn't affect how spread out the distribution is, just the coefficient in front. Okay, so I'm going to use either this formula for the variance, or this is even simpler. This is for the standard deviation. I asked you for the standard deviation, so this is just the square root of this. So let's use this result. All right, so that's what I'm going to do. I'm going to go here. I'm going to write, you could do it like this. The e of y is equal, let me make it bigger. So the e of y is equal to the e of 500 plus 100x. So this is 500 plus 100 mu of x. I'm demonstrating how I apply the rule. Now, what was mu of x? Looking at the problem, this one was mu of x. This is the mean, right? So this is the mu of x, the mean of the number of years. So, so this is going to be 500 plus 100 times 6.7. And the answer is 500 plus, you can move this decimal over 2, right? That's what the 2 zeros do to that number. So it's 670. So the answer is that the average bonus will be $11.70, and that's in dollars. All right, let's look at the standard deviation. The standard deviation was given here. This is the standard deviation here. So we know that the standard deviation, I can use S, of y is equal to, oh, you can't see that. Let's do that here. Okay, the standard deviation I could write it like this, is going to be, from the formula, B standard deviation of x. So this should be the B, remembering that we have y is equals 500 plus 100x. This is the B here. Okay, so since that's the B, it's just going to be 100 times 2.4. So the answer is the standard deviation is $240. That's the answer. All right. Good afternoon, Delia, Mylin. All right, so that's that answer. So if you just came in, just have a quick look at that. So just to recap, I use the rule for means to calculate the mean. The mean of the new variable created from x is just the same. It's the whatever I do to the values of x, I do to its mean. So I do treat it the same way. And I get this as the mean, $1,170 or 1,170. And the standard deviation, I don't use the shift term to find the standard deviation. I just use the number multiplied, so the 100. So it's 100 times 2.4. So let's go to the next one. Actually, let's do this one first. Let's do this one first. It's more fun. Okay, I have the answers here, but let's try not to look at those. So here, you have three variables, x, y, and z, and three constants, a, b, and c. And I want to create new variables from them, and I want to determine their variance. Now variance, not standard deviation, okay? So we know how to do that. For the sum of variables, to make a new variable, we did this at the end of last class. So what do I do? What do you remember that I do if you saw the video? I use a matrix. Or create a matrix to find the answer. Can I let you try that? Think you can try that? So your matrix will be, for the first one, you make a matrix with AX and BX and AX and BX, what am I saying? BY, and then AX and BY. And think of all the variation between those characteristics, between those variables. Okay, AX with AX, AX with BY. And then do it for the others. So give it a shot, write it out, and I'll give you the answer. Okay, I'm back. So let's see. Take this off. Oops. All right. Make this bigger. So this will be, okay, should I skip steps? Okay, I won't skip steps, but I'll clean up my work. So this will be covariance of AX with AX. This will be covariance of BY with AX. So I always put the row first, if you've noticed. With a matrix, you always put the row element first, and then the column element. You can't see that, right? All right, so that's what I have so far. Then covariance AX BY and covariance BY BY. So if you were with me yesterday, or if you know what I'm going to do, This one and this one immediately reduce. This one becomes, this one can be reduced, well, there's two steps. One is this becomes covariance x with x, and the a's go in front as a squared, right? And then the other part is that this reduces, covariance of x with x is exactly the same as the variance. That's what it means. So this is a squared sigma squared x. So those are the steps. I'll leave it there for a moment if you want to write it down, and then I'm going to clean it up. Same thing over here. This is going to reduce to b squared sigma squared y. And then these two are going to be identical. Even though these are reversed with the covariance, it doesn't matter because x and y are treated the same way. It doesn't matter the order they appear here. They had the same treatment in the formula, so it doesn't matter if a comes first or b comes after, because they're just being, the terms in the formula are just being multiplied, so it doesn't matter which one comes first. So these both reduce to covariance xy, I'll put it in alphabetical order, with AB in front. And this one as well, AB covariance xy. And there you have it. This is sigma, use this one, sigma squared, sorry, a squared sigma x squared. Two of these, and then b squared sigma y squared. Okay? So that's the answer. If you look down, I'm going to shrink it. If you look down here, that's the answer. Oops. That's the answer I give you. A squared, variance, so I use that symbol, which is just fine. Variance x, b squared variance y, and 2ab covariance xy. The next one, the next two I'm going to leave for you to try yourself and see that you can get the answers I've given you here. Here and here. All right? You should be able to generate that, and it's good practice to understand those results, where they come from. How's that? Any questions? Any questions? If no questions, I'm going to save this. And continue to another problem. All right, here's a finance problem for you. Sadie has invested 20% of her funds in treasury bills and 80% in an index fund that represents all U.S. common stocks. The rate of return of an investment over a time period is the percent change in the price during the time period, plus any income received. All right, so we can create her return variable, where x is the return on the T-bill. Sorry, yes, and then we're going to multiply that as our percentage, the percentage change. Sorry, if x is the annual return on the T-bill, and she's going to invest 20% of her funds there. And Y is the annual return on stocks, and that's going to be 80% of her investment. This will be her total return. Here's the information on each of those variables, mean and standard deviation of each variable. And I also give you this. Okay, so what is this for again? Well, sometimes you're going to get this level of detail. I'm going to give you the correlation between X and Y. They're not independent, so I have to use the formula, the longer formula, right? There is a relationship between them. Although it's small, right? This is almost zero. It's a very small interrelationship because usually decisions about T-bills are not, well in this case, not influenced by the stock market returns. Might not be the case because some people, when the stock market's doing poorly, they invest in bonds, so the returns can change. So, but here in this case, it's going to be a negative 0.11 in terms of this example. All right, so stocks had higher returns than T-bills on average. We know that. Stocks have higher returns than T-bills, and because they're more risky for people to invest in them, for them to exist, there's going to have to be a higher return on them. Okay. So I can calculate from there the mean, the new mean for this portfolio. So whatever I do to the values, I do to their mean. So the mean is a sum of the two means. And this is how I calculate the new mean. In terms of the standard deviation, I have to use the longer formula. Again, keep these formulas handy for your exam. You have them in the notes, but maybe outline them, put a sticky on it, use red marker or highlighter. But this is the formula you're going to use because the information you were given was on the correlation, not the covariance. So you have to use this longer form. So you need all this information. You need the variances and you need the correlation to get the variance. So you just plug everything in. This is just once you know which formula to use, it's really just algebra, or sorry, it's arithmetic. You just got to be careful in your calculation. If your calculator, I think it's a long formula, if your calculator doesn't hold long formulas like that on the screen, it won't, you won't be able to see this in the TI VA2 Plus that I asked you to buy. So maybe you want to do this in Excel. You can actually see what you typed, and in case you made any errors. All right, and that's fine. Just organize yourself. Make sure you can replicate this answer by yourself. So plug that in. Try plugging that in. Okay, no questions about that one before I continue? So now putting them together, the new mean is somewhere in between the originals, right? That's what it's telling you. It was 5 and 3%, but now the average of having both of those with more invested in the index fund is 11.56, closer to the return for the stocks because you have more invested in there. And then the standard deviation, or the risk measure, this is the volatility. It's much more volatile, the returns for stocks, than this one. It's very low. So when I put things together, the fact that I've mixed it together with a low risk investment will lower the overall risk when I combine them. I mean, you don't have to do this interpretation, but it's nice to know what the heck you're doing. So see, this one goes down to 14%. If I include in my investments some treasury bills that are less risky or lower standard deviation, it overall, having both of those in my portfolio lowers the overall risk. How did that work? Well, it's because of this negative. Because they're negatively correlated, this reduces the total variance, that these will sum together, but this will help bring this down. Okay, so we like that. That's an example of diversification. Even though it's small, it's still negative, so it'll reduce the overall risk. So you guys can review that. You can put my voice, slow my voice down if you want to hear that again. Hear that explanation at your leisure. All right, did I do all of them already? No, there's one more. Okay, there's two more. All right, so this one, aha, it's lots of fun. Now the answer for this is on the next page, but let's read it together. Suppose that the weight of checked luggage for an airline is a random variable x that is normally distributed with an average of 50 pounds and a standard deviation of 30 pounds. Suppose that the weight of carrying on luggage is a random variable y that is normally distributed with a mean of 10 pounds and a standard deviation of 3 pounds. So I'm going to do this. This is similar to the one we just did. I'm going to create a new variable because I'm interested in the total weight of luggage for each person, and then I want to consider 50 people. Now the catch is, oh, and here's the correlation between. So this shows that they're negatively correlated. It means if somebody has it means if somebody has a carry-on, or the larger their check bag, the slightly less, this is 0.1, the slightly less they're going to have in their carry-on bag, and vice versa. So if you have more in your carry-on bag, you're going to have slightly less in your check bag. And they're negatively correlated, but it's subtle. So what's the total for all 50 passengers? I'm going to create a new variable for 50 passengers. We're going to have 50 checked bags and 50 carry-on bags. And so so there's some variation in their weight. So I'm going to introduce the random variable because there's some variation. And with the characteristics of that, we're going to combine with the characteristics of the check bag. We're going to combine with the characteristics of the carry-on bag to create W. So I use this little I to say, you know, that they're different people, individuals, I for individuals. And then the question is, express the new variable as a sum of x and y. Well, that's what I've done. Okay, so W, since since this is a sum of two variables that are both normal, then the new variable is also normal. It has different properties, different mean and standard deviation, which we're going to derive, but the sum of two normal variables, or the linear transformation of two variables that are normal, is also normal. So remember that. I don't know if I wrote that in the notes explicitly, but that's the case. And I do prove it in the next unit. So you need to remember that. So how do we find the mean? The mean so I'm going to use the operator, the E thing, right? So E means, well, since W was equal to 50x plus 50y, whatever I do to the values, I do to the mean. So the values of x get multiplied by 50 and then added to the values of y that get multiplied by 50. So I'm going to do the same thing to the mean. So the mean of w is just 50 times the mean of x plus 50 times the mean of y. And when I plug those in, I get 3,000. What was the mean of x? Let's go back up. The mean of x was, oh geez, the mean of x is 50 pounds, and the mean of y was 10 pounds, you see? That's what it says. Read that again for yourselves. Hope this doesn't feel like a roller coaster when I zoom in and out. Don't get dizzy. If it's any better, follow along in your own notes. And then just reference my tablet. Okay, you see that? So that's going to be 50 for x and 50 for y. So when you plug that in, sorry, 50 for x and 10 for y. So when you plug that in here, you're going to get, this is going to be 500, and this is going to be 2,500, and they're going to sum to make 3,000. What about the variance? Well, let me put that back for a minute. Can you guys follow that? And the formula for the variance, since we were told that they do correlate, if the correlation was 0, you wouldn't have to do this, or this formula would just be this 2 terms, right? Because if this happened to be 0. But you're told that actually there's a correlation, so you're going to use this other form of the formula with the correlation in it. This one here. And go back, watch video from yesterday to explain, where I explain how that happens. But we substitute from this one for this one. So we find the information. We're careful, use Excel to make the calculation, to write it down and get an answer more efficiently. Because typing such a long string of calculations into your calculator can lead to errors. And make sure you can get this value. All right, this value here. So what's the variance of x and the variance of y? The variance of x, we were told. Maylin, do you have a question? Mylin? What were the variances? Variance, okay, so if you look here, the standard deviation was 30 pounds for the check bag, but 3 pounds for the carry-on bag. So that's the standard deviation. So what we need to do, oh wait, one more time. It was 30 and 10, okay, as the standard deviation. So that means that for this formula, and you can, I'll leave it up, and I don't know if you want to try and calculate it. You can check back with the video. So this was 30, but we have to square it, right? Because they gave you the standard deviation. And this one was 10, so you need to square it to get the variance. of y. And then, yes, 30 times 30 is 900. And then 10 times 10 is 100. Let me give you 3 minutes. Try and make sure you can compute that and find all the numbers. This one, so I've given you all the numbers here. This one would be 30, just the standard deviation. That's what that symbol means. And then this is 10. And then this one was negative 0.1. So that's all those values. See if you can punch those in. Use Excel. I think that would be the best. And see if you can get this number, okay? I'll give you 3 minutes. Once you get it, let me know. Trust me, this is much more meaningful if you actually make these calculations. Otherwise, it just looks really intimidating. Anyone get it? If you didn't get it, where did you go wrong? Or where do you think you went wrong? What went wrong? All right, I'm going to continue. And basically, this is the answer to all of that. So what does this say? It says that the expected value, the mean weight of all the passengers is 3,000 pounds. And the standard deviation, sorry, this is the variance. This is not even the standard deviation. To find the standard deviation, you would have to take the square root of that. Okay, you guys are going to work on this, right? So that next time on Monday, I'm going to ask you how you did on this calculation. Okay, you're going to practice this so I can get through a little bit more. So this is the variance. The standard deviation would be the square root of that. If you, anyway, try this problem, keep notes, and let me know next class, or email me about finding this value. Let me know if you still have trouble finding this value. But you need to practice plugging this in either in Excel or on your calculator. I put all the terms here. That's 50 squared, 30 squared, 50 squared, 30 squared, 10 squared. These are all multiplied and then added to this and then added to 2, 50, 50. Ah, you're a little bit off. You're just a little bit off, Mylin. It's not bad. You should be proud. Is it possible that you didn't use a negative here? Okay, just make sure you have a negative here for P. Let me make sure I use the right number. Is it -1? Negative 0.1? Yeah, negative 0.1. So if your number is too large, it might be because the negative. Okay, so check it later. I'll check back later. Okay, so then, so what are we going to, the last question is very practical. So now we've set up the distribution. Oh, you got it. Did you get it? Okay, so what's the probability that the total weight limit is exceeded? What was the weight limit? The weight limit, going back to the top, the weight limit was the total weight limit was 3,100 pounds. So 3,000. So what we're going to check, since this is a normal distribution, remember, because I'm adding two normals, I get a normal. So this new variable, W, we're going to check what's the probability that we're going to exceed the 3,100. So what we're doing is calculating the probability that, let me express this. So this is what I want to do. The probability that W is greater than 3,100. So I need to standardize that. We said W would be normal. So I standardize it. So it's going to be 3,100 minus its mean. What was the mean again? Let's go up. The mean was 3,000. We just calculated that, right? So the mean is 3,000. And then divided by the standard deviation. The standard deviation is the square root of this long number. That's a 5. Now when you do that, you get this. Sorry. You get this 0.067. Okay, so I've translated the word problem into this question. What's the chance that the weight limit is, W for weight limit, is exceeded? Now we're going to have more than 3,100. I put it here, and then I realize that's normal, so I can standardize it with the properties that we just derived. And then I'm solving this. I'm going back to the normal unit to remember, or to use the tool that I learned, drawing that picture. 0.067 is very close, and I want to go this way. So to go that way, I have to do 1 minus, right? Because the table only gives me the left side. So I use 1 minus what I found in the table to get this. Okay, so if you have trouble with the normal distribution, let me know. If not, that would be that. Okay, so we use 1 minus because if looking this up, you're just going to be told about this side, which is 0.5250, but I want this side, so I have to take 1 minus what I got from the table. And the answer is 0.47. What does it mean? There's a 47% chance that people are going to carry more on the plane. All right, so that's 50-50. That's too high. It's pretty high percentage chance. So it's okay. So that's that problem. Please let me know by email if you have any questions. I never got to say anything, but the quizzes were done. So I hope that your understanding, your comprehension, I saw on the quizzes yesterday. I'm very hopeful if that's the case. This is turning out to be successful. There's only one more problem here. So as I said, the final exam will vary one of these problems and you're going to have to answer it. So practice these, all right? Make sure you can punch things in, you know what to do. Maybe I'll leave you guys this one for practice. Again, it has the answers. All of these had the answer. It's just you need to practice punching it in your calculator. So you understand the mechanics. So here are these are referred to as, I referred to them in the regression unit as ex-ante returns. These are distribution. This is a distribution. For possible outcomes. These are driven by the different states of the economy. So there's only 3 possibilities. I've reduced the world to 3 possibilities based on some research, based on some analysis, some historical data, all the information I could gather, a prospectus of these companies. I was able to derive this distribution with 3 possible states of the world. Either the economy is going to be normal, it's going to experience a boom, or it's going to experience a recession. These are the chances of each of them. So the normal state of the economy is the most likely. Boom is the second most likely, and a recession is very slim. In the first boom state, this stock number 1 will have 35% return, but stock number 2 will have only a 6% return. Meanwhile, the market return will be 30%. That's very high. So it looks like the market and stock 1 return behave similarly, but stock 2 and the market don't. The opposite. In the normal state of the world, which is the most likely one, the market and stock 1 are similar, and then stock 2 is the opposite. And then in this least likely case, the market and stock 1 return are both low, but this is negative, so that's bad in the market. But stock 2 returns is positive. So there's some relationship, a negative relationship it looks, between 1 and 2, and 1 acts like the market and 2 acts the opposite. Something like that. Okay, so that's just looking at the data, which you should always do. Just look at your data, get a feel for what it's saying, and then let's answer these questions. I want you to make these computations, and you should use Excel to do it. I make it look really simple below because I just give you the answers, okay? If you want to go back to the regression unit, you can use the Excel table that I prepared and enter the values there, or just make your own Excel table to calculate, because these are distributions, you're going to have to calculate the weighted mean. I mean, these are distributions that have different weight on each of the possible outcomes. Okay, so this is not, you're not just going to average this to find the mean of stock 1 and average this. You have to use the weighted average. So that's a little more involved, even though they're just 3 data points. It's still, you have to pre-weigh and sum, you know, all those calculations we did way back in GDS. So look back and practice this, okay? You can make it on Excel. If you prepare the Excel table for the test, that would be Excel table that you understand to calculate the mean and standard deviation of all the stocks and the market return. You can calculate the covariance and correlation of stock 1 with the market and the covariance correlation of stock 2 with the market. Okay, so you need to calculate all of these things to understand their interrelationships. And then what I want is the mean and standard deviation of returns of a portfolio that is 75% invested in stock 1 and 25% in 2. So this is going to be a new variable. You're going to define so I've named each of the returns, like I named this return 1. Let me do that again. So I'm going to call these returns on 1 and these returns on 2. And I can create a portfolio. I can call it P or I can call it Y, which combines 25%. I'm illustrating how you got to do this. That portfolio is going to be is 75% in 1 and 25% in 2, right? So it's going to be 75% in 1 and 25% in 2. So you create a new variable, and from that you can find a mean and standard deviation. You have to know the interrelationships between R1 and R2 to do it. So mean and standard deviation returns. Okay, so this is going to take you a while. This should take you to answer all this using Excel for the first time. I don't know, maybe take 1.5 hours to work on this, and we'll talk about it on Monday. We'll talk about this one and the one I just did on Monday. I'm going to answer your questions, your problems with it. Okay, so make sure you practice that. Work on answering the assignment question and working in the forum with other people. Okay, and please keep in touch if you have any questions, anything I can help you with. We're done Unit 4 as far as I'm concerned, but any questions you have will be great. And Monday we're going to start, other than answering your questions about this, I'm going to start the binomial unit. We have a quiz, should be a quiz on binomial on the Thursday, so we'll have more than enough time to work on binomial on Monday, Tuesday, and Wednesday. So other than that, have a good weekend. Unless you have some questions, I'll give you a minute. I'll wait. If you have some questions, I'll answer them now. What I need to learn how to do is get rid of this delay. There's such a delay in what I'm sending out, and then when you're sending back, I have to wait quite a long time to hear back from you, and then you have to wait to hear back from me. Okay, so if there's nothing else, I'm going to let you guys go. Have a great weekend. Thanks for checking in. You're my core group. Okay, have a good weekend. Bye.